In this lecture, we're going to talk about observables and the RxJS library. By the end of this lecture, you're going to know what observables are, you're going to know what RxJS is and how it relates to observables. You're going to know what operators are, how to find out about the list of operators and how to understand an operator's function by using marble diagrams. And you're going to know how to build a simple application using RxJS. So streams so far are just a concept, an idea we've discussed. We link streams together using operators. So in our previous example, the add function is an operation, and specifically, it's an operation which combines two streams to create a third. An observable is a new primitive type which acts as a blueprint for how we want to create streams, subscribe to them, react to new values, and combine streams together to build new ones. It's currently in discussion whether or not observables make it into the ES7 version of JavaScript. However, we are still trying to roll out the ES6 version of JavaScript, so even if it makes it into the ES7 standard, it will be many years before ES7 becomes something we can code with natively. Until then, we need to use a library that gives us the observable primitive, and that's where RxJS comes in. RxJS stands for Reactive Extensions for JavaScript, and it's a library that gives us an implementation of observables for JavaScript. Observables might become a core part of the JavaScript language in the future, so we can think of RxJS as a placeholder for when that arrives. RxJS is the JavaScript implementation of the ReactiveX API, which you can find at reactivex.io. And the API has multiple implementations for different languages. So if you learn RxJS, you'll pretty much know how to write RxJava, Rx.NET, RxPy, and so on. Let's explain RxJS by working through a simple example. Now, to reduce file size, the RxJS library is broken up into many different parts. One main one and one for each operation you want to use. But for our example, we are going to use the rx.all.js library, which contains all of the operators in one file. So we're going to use Plunker again, and we've created a simple index.html file. We've added the rx.all.js library via a script tag. And we also have created a main.js file, which is where we will start adding in our RxJS code. Just a quick note, in Angular, since we are using the ES6 modules, we'll be adding in RxJS using the import statements. We're only using script tags here just to keep things simple. Let's open up main.js, hide the sidebar, and then open up the console at the bottom. The first thing we need to do is get an instance of an RxJS observable, which we do like so. Now, an observable isn't a stream. An observable is a blueprint which describes a set of streams and how they are connected together with operations. I want our observable to create a single stream and push onto that stream a number every second, and a number which increments by 1 every second. And with RxJS to define an observable to achieve the above, we would use the operator interval. The operation interval takes as the first parameter the number of milliseconds between each push of the number onto the stream. So we're saying 1,000 milliseconds, so a second. So every second, the interval operator is going to push a number onto the stream. Let me explain what's going on with an animation. So this graphic represents an observable chain. The vertical line is the stream and the interval text is the interval operator. And what interval does is every second it publishes a number onto its output stream, a number which increments by 1, like so. Three, 4, 5, and so on for infinity. That's what the interval operator is doing. In RxJS, operators act on an observable and return an observable with the operator applied. So we can chain operators together, creating an observable chain. So let's imagine we have another operator called operator 2. Interval itself returns an operator. Operator 2 is another operator which returns an observable. Operator 3 is another operator that acts on that returned observable and again returns another observable, and so on and so on. So we can actually chain multiple operators together on an observable. Each of these operators would be reacting to whatever piece of data the previous operator emits on its stream. The next operator subscribes to that stream and then performs some processing, emits something onto another stream. The next operator subscribes to that stream and then performs some processing and emits something onto the next stream, and so on and so on and so on, creating what we call an observable chain. But if we try and run this, we can see that nothing's happening to the console, nothing's getting printed out, at least nothing from the observable chain that we've created. Well, one reason is because the observable is cold. It's not actually pushing out any numbers. Now the observable will become hot and start pushing out numbers onto its first stream when it gets its first subscriber. So we need to subscribe to our observable. We subscribe to an observable by calling subscribe, like so. When we do so, it turns the observable hot, so it starts producing events. And the subscribe function also lets us pass in a callback function so we can react when anything is pushed onto the final stream in the observable chain. In our callback function, all I'm doing is printing out whatever is getting emitted onto the end of the observable chain. So now, if we run our application and we look at the console, we can just see the effect of the interval observable. It's just publishing out a number which is incrementing by 1 every second, and we're just printing that out to the console. But if you look at the console, you can see it just keeps on printing forever and ever and ever. Just keeps on producing all the time. Now for our example, we just want the first 3 items. So we use another operator called take. So we pass to the take operator the number of items we want to take from its input stream, the first stream. It then creates a second stream and only pushes onto that second stream the number of items we've requested. Let me show you with an animation. So our observable chain now has 2 streams and 2 operators being applied to it. When it first runs, the interval operator publishes 0. The take operator then sees a 0 being published and then publishes that onto its output stream. And then a second later, interval publishes 1. Take then sees that, publishes 1. Interval publishes 2. Take publishes 2. But then interval publishes 3. And because we've configured take to only listen to the first 3 events, it ignores the 3 and the 4 and the 5. Etc., etc. That's all that the take operator is doing. So now if we ran this in our application, subscriber 0, 1, 2, and then it stops because we said we only want to take the first 3 items from the input observable, the input stream, and publish it to the output stream. Okay, finally, I want to add another operator called map. This operator takes as input the output stream from take, converts each value to a date, and pushes that out onto a third stream. Let me explain what's going on here with another animation. We now have an observable chain with 3 streams and 3 operators. When we subscribe, interval starts publishing out. It publishes out 0, takes 0, publishes that out to its output stream. Map notices the 0 and then runs it through its internal function, which essentially replaces that integer number with just a time in seconds since the epoch. So some number. And then interval a second later publishes out another number. Take then takes that number. The map then notices it and publishes another date. Interval, take, map, and then interval. And because take ignores, it only takes the first 3 items, nothing else happens. And then interval just keeps on publishing out. So now if we ran our application, let's see what gets printed to the console. There we go. Now, it might initially look like that number is not changing, but if you look at the 4th digit there, you can see it's actually incrementing by 1, and that's because this is in number of milliseconds. So this is the time exactly 1 second after the first one, exactly 1 second after the second one, and the third one there, which is what we'd expect because interval is publishing every 1000 milliseconds. So this example showed a very, very small subset of the total number of operators that's available to you when using RxJS. The hardest part of learning RxJS is actually understanding each of these different operators and how to use them together to solve your problem. So even though you're writing JavaScript, learning RxJS is closer to learning another language altogether. And if you go to the official documentation, you can find the list of official operators by clicking here. And at the bottom of the page, they have essentially kind of a helpful little place for you to figure out which operator you might need to solve your problem. So it has a kind of a human readable problem description. And at the end of it, it describes the observable you may need to use to solve your problem. The documentation for the map function that we just used is here. Let's have a quick look at it. I mean, trying to understand an operator by just reading some words is pretty difficult. And that's why in this lecture, I've tried to use animations as much as possible. So to help explain what each operator does, the Rx team used something called a marble diagram to visually describe the operator's function. And then this, what you're seeing right now, is the official marble diagram for the map operator. The line at the top represents time going across. So time goes from left to right. The line at the top here is an input stream, and the line at the bottom is the output stream. The little circles are individual items on the input stream. And the bit in the middle is the actual operator itself. So in this example, the operator is a map function which multiplies each marble, each item, by 10. So in this example, the number 1, once it goes through the map, produces 10, 2 produces 20, and 3 produces 30. Now the cool thing about these diagrams is they're actually interactive. So this one isn't particularly useful because there's no logic in it other than just multiplying the number by 10. But let's have a look at another one. Let's have a look at the take operator that we used. So you can see this one is just a little bit more complicated. So this is take 2. On the input stream, we have 4 items being published out, 1, 2, 3, and 4. And on the output stream, we only have 2. So if I moved 1 to here, it's fine. Then there we go. So we can see that actually event number 3 is the only one it would see. And so on, so on. So if you're struggling to understand what an operator does, I definitely recommend you go and read the official documentation and just have a play around with these marble diagrams if you can. To summarize, observables are a blueprint for creating streams and plumbing them together with operators to create observable chains. RxJS is a library that lets us create and work with observables. We can subscribe to an observable chain and get a callback every time something is pushed onto the last stream. By default, observables are cold and only become hot when they get their first subscriber. Learning RxJS involves understanding all of the operators that are available and how to use them together. And we use marble diagrams to help explain how an operator works. Now, in this lecture, we used RxJS in isolation. In the next lecture, we're going to look how to use RxJS in Angular itself.